Good day, grade 10. Today, we're going to talk about probability of compound events. What are your chances? How is this probability of compound event be different from the probability of a single event? Before anything else, I want you to think, what is the probability that an event may happen twice at the same time? So, this will be the focus of our discussion for today. But before anything else, let us recall first the probability of a single event. When we talk about probability, it is always a number between 0 and 1. 0 is the smallest probability that an event will happen, or it refers to uncertainty or impossible, meaning to say that it is impossible to happen. The highest probability is always 1. It means that 100% an event is possible to happen, or it is always certain. Remember that for us to express probability of a single event, we can express it into three ways. First, fractional form, from 0 over 1 to 1 over 1. Second will be in decimal form, from zero point zero to 1.0, or either percentage form, from 0% to 100%. The desired outcome of an event is called as success, and the other is failure. So the probability that an event will happen, we called it as success. And how are we going to get the probability of failure? Just subtract it from the highest possibility, which is 1. Our formula enables for us to get the probability of a theoretical event, that is always the number of possible outcome over the total number of outcomes. I'll repeat, the probability of event formula, the number of possible outcomes over the total number of outcomes. So say for example, a box containing 5 green balls, 6 white balls, and 9 yellow balls. What is the probability of getting a green balls? Remember that in able for us to get the total outcomes, we need to add all the possible outcome in an event. So in a box containing different colored balls, there are 20 balls in all. Therefore, the probability of event is there are 5 green balls out of 20 colored balls, and the possible outcome is 5. Applying the formula for probability of event, we have 5 over 20. Express it always in simplest form is 1/4. 1/4 in decimal is 0.25. In the other hand, 25% probability. When we talk about the union or intersection of two events, we called it as the compound event. And this will be the focus of our discussion for today. Say for example, of compound events, the combination of two or more events, rolling two dice, dealing two cards at the same time, which is having a condition. So this will be the formula enable for us to get the probability of compound event. First, if A and B are referring to two events, then the probability of two events is probability of event A plus the probability of event B, or the possibility that an event 1 will happen plus event 2 will happen. This will only be applicable if the events are mutually exclusive or having no intersection. Remember, no intersection meaning to say that no same event will happen at the same time. Remember, for a mutually exclusive event, the sum of probability event 1 plus the probability of the event 2. Second one, if two events are mutually inclusive, then the probability is the probability of the first event plus the probability of the second event minus the probability of the intersection of two events. It means that there is an outcome that share by two events. Kindly look at our example. The first diagram shows an event having intersection. Same with the second diagram. The third diagram shows that an event is mutually exclusive. Kindly look at our example. A card is randomly selected from a deck of 52 cards. What is the probability that it is an ace or a king? Kindly think of our problem. If that problem or if the events may happen twice at the same time, or if that is a mutually exclusive or inclusive event. That event is an example of a mutually exclusive event because an ace and a king doesn't have an intersection or doesn't have a common event. Therefore, we are going to use the first formula in getting the probability of compound event. That is the probability of the event 1 plus the probability of the event 2. Applying it with our given, the probability of the first event in getting a king is 4 over 52 because there are 4 kings in a standard deck of 52 cards. The probability of getting an ace in a standard deck is also 4 over 52 because there are 4 aces in a standard deck of cards. Combining them together, probability of the first event plus the second event gives us 8 over 52. Always expressed in terms of lowest term, it will give us 4 over 13. Got it? For our second example, a card is randomly drawn from a standard deck of cards. What is the probability that the card is a red card or a face card? Same process that we are going to apply in this problem is to think if the events that will happen is a mutually inclusive or a mutually exclusive event. If we are going to select a card from a standard deck, is it possible that we can get a red card or a face card at the same time? Yes, it is. Therefore, we can conclude and we can say that this problem is a mutually inclusive event in which the event can happen at the same time rather as we draw a card from a standard deck. As it is a mutually inclusive event, what are the possible events that may drawn at the same time? So, we will let the first event as getting a red card. We all know that in the standard deck of 52 cards, there are 26 red cards in all. Therefore, the probability of the first event is 26 over 52. In the other hand, we will let the event be as getting the face card. And in a standard deck of card, there are 12 face cards, namely 4 jacks, queens, and 4 kings. Because this is a mutually inclusive event, there is an intersection of both events. That is can be red card or a face card. And there are 6 possible outcomes. It can be a red king, red queen or a red jack. Therefore, applying the formula, the sum of the two probability of event minus their intersection, so we have 26 over 52 probability of the event 1 plus 20, 12 over 52 probability of the event 2 minus 6 over 52 intersection of their event. It will give us a probability of 0.62 or 62% probability that we can select a red card and a face card. For your task in this day, you need to answer this on your math notebook. Thank you for listening in this video. I hope you have learned something today.